Hello viewers, you're welcome once again. We are still under logic. Christ the Almighty God's algebra. In our last tutorial, we treated law of complement by conjunctive statement. Today we are going to treat law of complement by disjunctive statement. Let us start. Law of complement. P or not P is equal to T. This is an example of law of complement. That means P or not P is equal to T. That is law of complement by disjunctive statement. Why is it called law of complement by disjunctive statement? It's because of this or connective that combines P and not P together as a single statement. So this or make the statement to be disjunctive statement. So by reason of being a disjunctive statement, we call it law of complement by disjunctive statement. If you look at this equation, you will find out that it is logical equivalent. The equation is logical equivalent because wherever the left hand side of the equation is true, also the right hand side of the equation is also true. In the same vein, whenever the right hand side of the equation is false, also the left hand side of the equation is also false. But in this case, when you evaluate this P or not P, it will give us tautology throughout. There's no possibility of getting falsity when you evaluate P or not P. The same thing here, when you evaluate this T, it is constant. It always gives you T. And this one is constant, this one is also constant. So there is no case of variable. That means we have the value to be T and value to be F. I mean falsity and truth. Always truth, always. So since that is the case, so that it is logical equivalent. I mean it is law. Now let us prove this statement that P or not P is equal to T. Proof. Suppose P or not P is equal to T. We assume that the statement is true. We assume that the statement is true. That means P or not P is equal to T. As I said earlier on, that the statement is logical equivalent because whenever P or not P is true, T is also true because it's constant. And whenever T is true, also P or not P is also true. We see that it's logical equivalent. Since the equation is logical equivalent, we can transform it to biconditional statement. That means we can transform this statement, this P or not P equal to T, to biconditional statement. If and only if P or not P, if and only if T. You find out that whenever the left equivalent is true, also the right equivalent is also true. And whenever the right equivalent is true, also the left equivalent is also true. So whenever you want to write the statement, There's no possibility of getting falsity, always truth. You say that the statement is tautology. So is tautology being justified by biological equivalent. Now, see, this statement is tautology, that means P or not P, if and only if T is tautology. We can also transform it to conditional statement and it will still preserve tautology. As if and only if P or not P implies T. And you have now transformed it to conditional statement. And whenever the antecedent is true, also the consequent must also be true. So, since it is the case, whenever we believe this statement, there is no possibility of falsity, always truth. We say statement is tautology. He said that the statement is tautology. Is tautology being justified by logical implication? By logical implication. If and only if, now since this statement P or not P implies T is tautology, we then deduce that P or not P exists. Since it's tautology, that means P or not P is a proper implication of T. And if it is proper implication of T, we then say that P or not P is logical implication of the consequent T. P or not P is logical implication of T. Is logical implication of T. Let's write it very well. Is logical implication of T. Yes, you said that P or not P is logical implication of T. That means this antecedent is implication of the consequent T. So if this is true, this P or not P is logical implication of T is true. Also, this must also be true. So if and only if P or not P is equal to P or not P. That means P or not P is equal to itself. It is true that P or not P is equal to itself because it's logical equivalent. In the sense that whenever the left hand side of equation is true, also the right hand side of equation is also true. In the same vein, like here, is always truth. So whenever the right side of equation is true, also the left side of equation is also true. We say it's logical equivalent. It's logical equivalent. So it is true that P or not P is equal to P or not P. That is the logical implication is equal to itself, being justified by identity. being justified by identity. If and only if P or not P is equal to, he found out that this P or not P is, when you write it, it gives us constant constant truth. In any case, in each case evaluate it, in each of the possible combination of the P and not P, it will give you truth. So you say that it is constant. P or not P is constant true. So if it's constant true, you say it's equal to T, and tautology is equal to T. Because it's tautology is equal to T. It's equal to truth. That the statement is true. Because there's no possibility of getting falsity in the violation of the statement P or not P. So you say that it is true. It is T is equal to T. Being justified by tautology. Because this one is constant true, also T is also constant true. So this one is tautology, this one is also tautology because it's constant true. So it's being justified by tautology. By tautology. You have seen that I have now proved that P or not P is equal to T. So then conclude. Say thus P or not P is equal to T. Since the equation P or not P equal to T is logical equivalent, that means it is law. It's logical equivalent. We are going to prove the converse. So by the principle of causality, we then establish that P or not P is equal to T, is law of complement by disjunctive statement. So conversely, T is equal to P or not P. We have seen that this T at the right side equation here has now become T at the left side equation here. P or not P at the left side equation here has now become P or not P at the right hand equation here. That to say that it is now is converse now. Let us prove it. So suppose T is equal to P or not P. We are assuming that the statement is truth. And you know that the statement is logical equivalent. Because whenever the right hand of equation is whenever the left hand of equation is true, also the right hand of equation is also true. Whenever the right hand of equation is also true, also the left hand of equation is also true. You say it's logical equivalent. Since it's logical equivalent, we are going to transform it to by conditional statement. If and only if T, if and only if P or not P. You find out that whenever the left equivalent is true, also the right equivalent is also true. Whenever the right equivalent is true, also the left equivalent is also true. So if you evaluate this statement, there's no possibility of getting falsity, always truth. You say that the statement is tautology. Is tautology being justified by logical equivalent? Being justified by logical equivalent. You go to this side. So if and only if T implies P or not P. Now, because of this T, if and only if P or not P is tautology, we also transform it to conditional statements and it will still preserve tautology. That's why I say that it is T implies P or not P. And you see that whenever the antecedent is true, also the consequent must also be true. So whenever we make this statement, the possibility of getting falsity always truth. You say that it is tautology. You see that it preserves tautology. You say that the statement is tautology. Is tautology being justified by logical implication. Logical implication. Now you have now transformed it. You have now found out that it is T implies P or not P is tautology. Be justified by logical implication. We then deduce that this T is a proper implication of P or not P. That means the consequent P or not P. Now, since it is proper implication of P or not P, you say that T exists. And if T exists, you say that it is logical implication of the consequent P or not P. So if and only if T is logical implication of P or not P. So T is logical implication of P or not P. If it is true that T is logical implication of P or not P, also this must also be true. So if and only if T is equal to T. That means T is equal to itself is logical equivalent. It is true that T is equal to T is logical equivalent. That to say that whenever T is true, T is true. Whenever T is true, T is true. What I mean that T at the left side of the equation is true. Also, T at right side of the equation is also true. Whenever T at the right side of the equation is true, also T at the left side of the equation is also true. We say that it's logical equivalent. So it is true that T is equal to 2 is logical equivalent. Being justified by identity. Being justified by identity. We continue. Say that if and only if T is equal to, you see that this T is constant. T is constant. Is written as T. The constant is equal to T. So, and you see that is equal to law of excluded middle. That means P or not P is a law of excluded middle. And when you relate the law of excluded middle, that means P or not P, it will give us T, and give us tautology throughout. Truth throughout. In any case, to give us tautology throughout means that it is constant. It is T constant, which is equal to truth. So we say that T is equal to P or not P. P or not P. Being justified by law of excluded middle. Being justified by law of excluded middle. We have now proved the converse, that T is equal to P or not P by law of excluded middle. We then conclude we said thus T is equal to P or not P. We have now proved the converse. I mean the converse, T is equal to P or not P. We have now proved it. Since I have now proved the converse, by the principle of essentiality, we then establish that P, since I have now proved converse, we then establish that P or not P is equal to T. Is law of complement by disjunctive statement. Therefore, P or not P is equal to T. Now I have now proved that law of complement exists in disjunctive statement, and law of complement by disjunctive statement exists. So at this juncture, we withdraw our curtain. Thank you, viewers.